Hello and welcome to our in-class practice for trigonometry part 1. In our video lesson we talked about using sine, cosine, and tangent and the trig ratios to solve for a missing side. And we're going to do a little bit of practice with that today. So let's practice with a little bit of trig ratios to start with to start our day. Now just as remember we use the mnemonic SOHCAHTOA, and I personally like writing it like this, SOHCAHTOA, and it helps us keep the ratio in order, and it still spells out the SOHCAHTOA. But also remember, we could write it out the long way. You could say sine theta, remember that's for our angles, is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. And then the last one, tangent theta is equal to opposite over adjacent. Okay, so there's our trig ratios, and we're going to use these throughout the entire practice, starting with number 1. Notice all of the sides here are given, so this is just a exercise solving for specific trig ratios, okay? Now, also notice that it talks about different angles here. Angle J is the first 3, and then we repeat the sine, cosine, tangent, but with angle L, okay? So I'm going to do this in 2 different colors, just to help illustrate this. So first color, let's use green for all of the J's. Okay, so we're looking at it from this perspective, from the angle J perspective. From the angle J perspective, well, 20 isn't going to change. This is your hypotenuse. 12 is your opposite side because it's directly opposite of the angle. And then 16 is the adjacent side. So we could write all these trig ratios here. So sine of J is sine of theta, because this is the angle we're looking at it from, is equal to opposite, which is 12, over the hypotenuse, which is 20. And then obviously, yes, we could simplify this. 12 over 20 becomes divided by 4, 3 over 5. But ultimately, this is good enough for now, okay? Then we do the cosine from that same theta. So cosine theta is adjacent over hypotenuse. The adjacent side is 16, over hypotenuse, which is 20 again, and we're good to go there. And then the last one, tangent theta, because we're still using that same angle, is equal to the opposite, which is 12, over the adjacent side, which is 16. Okay. Now we're going to repeat this, but we're going to look at this from the different angles perspective. So I'm going to put in red. This is going to be our second theta, or L theta, okay? So looking at it from this perspective, or I could put a little person here, we could say sine of theta, or sine of L, is equal to, in this case, opposite over hypotenuse is not the same because the opposite now is 16. And the adjacent side now is the 12. Hypotenuse still stays the same. So doing this accordingly from this new perspective, opposite over hypotenuse is 16 over 20. Cosine theta is equal to adjacent 12 over 20 hypotenuse. And the last one, tangent theta, is equal to opposite over adjacent, which would be 16 over 12. Okay, so that is just a little bit of practice doing the actual trig ratios and setting them up. Now, solving them is a different story, especially when we're solving for a specific side and when we're actually given an angle here. So let's look at what we have. We're looking at it from this perspective. So the x side is actually the opposite side. 11 is the adjacent side, And you don't have to put the hypotenuse here if you want to, just to clarify, you can. So in this case, we need to use the opposite and the adjacent side. Oops. So opposite and adjacent, because those values are actually given. So opposite and adjacent is their tangent. So we're going to say the tangent. And instead of saying theta this time, we're going to use the actual angle. 64 is equal to opposite x over adjacent 11. Now, to get x by itself, we multiply both sides by 11. So if you want to do this now, you absolutely could. And then in your calculator, you could make sure, one, you're in degrees, which you are, or which I am. So make sure you are. Then we could do 11 times, hit the tangent button, which is right in the middle of our calculator, and then enter 64, close the parentheses, and we get a value. Now, know that this is a side, right? It's the opposite side. So we're going to say x is then equal to, and then it says round to the nearest hundredth. We can say 22.55 because the 3 will round down. Okay? Let's try another one. So let's label, we're from this perspective now. So let's look at what we have. We definitely have the hypotenuse. And we have the adjacent side. So which trig function has adjacent and hypotenuse? That is the cosine function. So we're going to do cosine of theta, which is cosine of 29 degrees, is equal to adjacent over hypotenuse, which is x over 29. So once again, to get x by itself, we multiply both sides by 29. 29's on the right cancel. And then we can say x is equal to, and then in your calculator, we can do all of this work all at the same time. 29 times cosine of 29 degrees is equal to 25.363. 25.363, which will just stay rounded to 25.36. We are done. Okay? Now, what happens if the hypotenuse is, or the denominator is the one that's missing? Let's find out. We're looking at it from W's perspective this time. So we're going to say the x is the hypotenuse, and then the 12 is the opposite side. Which trig function uses opposite and hypotenuse? Use sine. So we're going to use this angle for our theta. Sine of 63 degrees is equal to opposite over hypotenuse. Then, to solve for x, we actually, and since x is in the denominator, we need to multiply both sides by x first. X is on the right will cancel, and we get a new line. X times sine of 63 degrees is equal to 12. Then, to get the x by itself, we should divide both sides by sine 63. And then we get x is equal to, and then we can plug this into our calculator. Okay, so let's pull out our calculator again. We're going to do 12 divided by sine of 63, close parentheses, and we get 13.467. So this one will actually round up to 47. So 13.47. Okay, let's try number 5. Now we're changing perspectives, not changing, but we're using A's perspective. So x should be our opposite side. And then 7 is our adjacent side because it's next to it. Now don't be confused because this is technically also next to it, but this is our hypotenuse because they're directly across 90 degrees. So we can do our, which trig function uses both adjacent and opposite. It's our tangent function, or tangent. Tangent theta, which is tangent 36 degrees, is equal to opposite over adjacent. This one's easier because your variable's in the numerator, so all we have to do is get rid of that divide by 7 by multiplying both sides by 7. And 7's on the right cancel. We should get x is now equal to, we'll do 7 times tangent of 36, close the parentheses. You get 5.085, which will round up. X is equal to 5.09. Okay. All right. Let's try one more. And let's look at let's look at this one, number 8. So, number 8, here's our perspective. We're looking at it from B, so B, that means our hypotenuse is directly across still. And then from this perspective, we have 11 as our adjacent side because it is next to. Now, which trig function uses adjacent and hypotenuse? That is our cosine. So we say cosine of adjacent, or cosine of, our angle 37 degrees is equal to adjacent over hypotenuse. And then now we have to do a little bit of extra math. We need to get the x by itself. We can't do that until we multiply both sides by the x. Then we get x times cosine 37 degrees is equal to 11. Divide both sides by cosine 37. And then x is equal to, and we'll plug this in our calculator, 11 divided by cosine 37 is equal to 13.77. So a lot of this is just kind of identifying your sides properly, using the right trig equation, and plugging everything in and solving, okay? Now, it's very, very useful to have this memorized, your SOHCAHTOA or these equations done properly. So please try to do it without, or one, definitely write this on the top of your homework, and then two, try to get these memorized as soon as possible, okay? All right, if you have any questions, please ask, and I'll see you in the next one. Bye.